Welcome to this session. In this session, we'll be talking about the relational data model. In our last session, we spoke about data, we spoke about how data is generated, the problem with large amount of data, and also we spoke about how database management system help address these problems. And we try to define what database is. In this section, we'll be focusing on the relational data model. The relational data model is a method for organizing and storing data in a database as a collection of tables, where each table represents a specific type of data, and the table is made up of rows and columns, where each rows represents a single record, and each column represents information about a specific field. So basically, we have this relational model. We have the data, we have the table, we have the rows, and we have the columns. So the data is stored as rows in our table, and the table basically is data about the class of an object. And let's just take an example to understand what I'm trying to explain. So let us kind of envision we want to create a database of parks in a city. So we want information about the location of the park, the name of the park, and the size of the park. So we start by creating a table. So this is like a representation of the table. So we start by creating a table, and we create this table and we call the table parks. And now the park would have data. So these are like the data in the park stored in these rows. And now the entire table is the data about an object class, and the class of this object is the park. And now the row represents a single record. So each row, for example, the first row, it represents the whole record about the park named Central Park. And each column represents specific data field. So now this column represents the park name, this column is basically for the park size, and these two columns are for the location of the park. So, and also the column has a unique data type. For example, we have strings here, we have integers here. Each column would have a unique park, and each row in the parks table will represent a single park and contain information for each of the column. So this is the example we have here. I hope this is clear. So next we'll be talking about the basic rules of the relational databases. The basic rule of the relational database are also known as the rules of normalization. There are a set of guidelines that are followed to basically ensure that data is stored in a consistent, organized, and efficient manner. There are several normalization rules, and we'll be talking about the first three, which are the most common rules. So we'll be summarizing all of these rules. The first normal form, the second normal form, and the third normal form. So instead of like just boring you, reading it back to you, we'll just try to summarize it. So the very first rule is that each column in the table must contain only atomic values. So what we're trying to explain here is that we can only have one value of the proper data type in each cell. So if you go back to the database we have here, if you go back to the table we have here, rather, you can only see one value of the proper data type in each cell. So the value could be a string, it could be an integer, but we cannot have, for example, two different fields. For example, maybe first name and last name. We would have to create two different columns for that. You can have both in one column. It has to be two different fields. So that is what the very first rule is trying to explain. Another integrity rule is that each row must have a unique identifier. So we must have a unique way to identify each row to differentiate it from other rows. And this is known as the primary key. So we'll be talking about this shortly. And also talking about other integrity rules, the primary key must not be null, but other fields in the table could be null, but the primary key column, the primary key row rather, must never be null. And when other values are unknown, null is actually permitted, but not for the primary keys, but not for the primary key rows. And finally, the rows in different tables are related using primary keys as foreign key in another table. So that might be complicated, but when we talk about the differences between primary and foreign key, I think we would understand. So now let's talk about primary keys and foreign keys. So in simple terms, a primary key is a unique identifier for each item in a table. while a foreign key is a way to reference the primary key in another table. And it might seem a little bit confusing now, but we'll explain in the following slide. So the foreign key basically creates a relationship between two tables, and it's basically ensures consistency or integrity of the data. So let's dive in deeper. So now let's envision an example whereby we are trying to create a table of different countries, and we are trying to get the name of the country, the population of the country, and other attributes of the country. The same thing we are trying to do for a city as well. We are trying to get the name of the city, the population, where is the city located, and what's the capital of the city, and also a final table where we'll talk about rivers in the particular city. So once we want to like create a table like that, we have something like this. So basically the capital letter is trying to tell us about the table. So the items in capital, so this country is a table. Like, let's assume this is the first table, this is the second table, and the river is the third table. So now the attributes, like the column, right? The column are like the name of the country, what continent is the country in, what is the population of the particular country, what is the life expectancy in that country, the GDP of that particular country. So this is like a table, right? This is a full table. And now the item underlined is the primary key. These are like unique identifiers for this particular table. We know we cannot have for primary keys, we cannot have two values being the same thing. So the only way we can identify, for example, a country might be different countries might be in the same continent, but different countries can never have the same name, right? So the primary key here is the name. That is why it has been underlined. It is a way to uniquely identify the country. Now two countries might have similar GDP or similar population, but they can never have the same name. So that is why the primary key is a way to uniquely identify items in a table. And now the same thing goes for the city, and the same thing goes for the river. So if you want to look at the primary keys, now this is how we write them. So the primary keys are the country.name, city.name, and river.name. So now how do we link the countries to the cities, and how do we link the rivers in the city to the city table? So that is why earlier we defined the foreign key as a way to reference the primary key in another table. So now we'll just look at that in a bit. So for foreign key is basically the column of a table that appears in another table where it is like previously the primary key. So for example, if you look at this country table, right, the name right here is the primary key. But now when we are coming to this city table, how do we reference the city, right, that a country is currently in? We can reference the city that a country is using the country name, right? So now this particular column in italics, so I kind of did the foreign keys. I wrote the foreign keys in italic just to like differentiate them. So now this country is actually an attribute of this country table, right? So it is showing that it is basically showing a kind of connection between the country table and the city table. It is kind of a link that it links up the country and the city table. We also have river now. Now river is also a table, right? And it has the attributes name, origin, and length. Now where is this river originating from? The river has a source, right? It's a source from a particular country as well. So now we are trying to see this origin, which the origin is the foreign key in this river table. So now the river is originating from a particular country. So the river is storing the details of the country it is coming from. So now when we want to look at the foreign keys in this table, we look at the foreign keys this way. So now the city dot country, now this is saying the city dot country, this particular column is storing the attributes of this city dot name. It is storing the names of it's storing the names of the country. So this is a way we can kind of have a link, a kind of join, right? We can use this particular similar attributes to like join the city and the country together. The same thing goes for the river dot origin, right? The river dot origin is a foreign key. It's a foreign key in the rivers table. Now it is um, referencing the name of the country, right? So we can know, oh, this river is actually originating from this particular country or something like that. We would kind of explain in more details using diagram in the next session, but I hope this gives an idea of what we're trying to talk about. And I forgot to mention about primary keys. Basically, sometimes we have composite primary keys. So what composite primary key means is like the combination of attributes. Sometimes you might want to use two different values to represent the primary key. An example could be when we have a point table, you might want to use the x and y coordinates to represent the primary key. So I forgot to mention that. So that is that about composite primary keys. But normally this is what we'll be working with a lot. So this is a visual representation of what we had earlier. This is a visual representation of it. So we have a table. This is the country table, this is the city table, and this is the river table. So now this is the unique identifier, which is the primary key for the country table, the country.name. The same thing with the city. The city.name is the way to uniquely identify every item in the city table, and the same goes for the river. Now we want to know, we want to kind of form a link. We want to link up the city and the country. And now the way to link up the city and the country is to look for what they have in common. Now what they have in common is this country, is this particular colon. They have this particular colon in common. Now because the country.name here is the same thing as the city.country. So now we can use this to uniquely join these two tables together. It is a way to like reference what we have in this country table in the city. So hence this city.country in the city table would be the foreign key. The same thing goes for the river. The river.origin would be like, where's the river originating from? So let's say river the river named St. Lawrence, the origin is from US. So this is a way to join the attributes of this particular table to this particular table. So that is what the primary and the foreign key does. I hope we understand this. I try to stress it, but with diagrams next week we'll probably have a deeper understanding. And now there are some integrity rules that must be maintained for the relational data model. And now the very first rule is about the primary key. Every table must contain a primary key. Like it is just a must. Like every table must contain a primary key. And the other rule is about the entity rule. The entity rule is about the value of a primary key of a row must never be null. You can never have null values in the primary keys. And the third rule is about the referential integrity. So the referential integrity basically helps to ensure that the relationship between tables are maintained and that the data is consistent between related tables. For example, if a record with a foreign key is deleted, the referential integrity rule can be set to either cascade the delete or to either cascade the delete to the related record or prevent the or to prevent the delete from happening at all, just to maintain data consistency. So let's talk about the relational model when it comes to like spatial data, and this is also known as the object relational model. This model basically enables the integration of spatial data into a database. Now this is where we can have our geometries like the point, line, and polygon into our database, allowing for the use of SQL and other relational data tools for spatial analysis and querying. Additionally, the relational model provides a structured way of organizing and storing spatial data, making it easier to maintain and manage. So we have some common examples of the relational database that support spatial data, and this include Postgres, Oracle Spatial, and Microsoft SQL Server. So we have others, but these are like the ones I could think of at the moment. So this will be a wrap for this particular lecture, and in the next session we'll be talking about the database design. So do stick with us, and we'll see you soon.